Everybody can see the screen now, huh?
Yes, sir.
Yes, sir.
Okay. All right. Good. So what we're gonna do now is let's look at question number one lah. Yeah. Now, for your question number one, oh sorry, for your question number one, balik question number one. For your paper one, there will be five kali ya. There will be five component. One is the what you call the general physics, yeah. So general physics include a lot of things lah, like the unit, uh, kinematics. We also have dynamics, yeah. So there's a lot of stuff in this kinematic, and then we have also forces. We have pressure. We also have moment, and then we also have the collision, which is also about the momentum, and then we also have energy, and then we also have work and power, and then that we also have what we call the deformation. Yeah, deformation is also part of the general physics. So this one is about the Young modulus lah. Okay, this is the one that cover for general physics. So this is the first one. So the second one that will be covered here will be wave. Yeah. So this is another part. So there are one part. There are two part. So in this part, we will be study about wave uh, detail. Yeah. For example, the period, the frequency, the wavelength. We also have the phase different. And then also in wave, we also study superposition, yeah, superposition. And then we have the diffraction grating, yeah, diffraction, diffraction, oh, diffraction grating. And we also have the Young slit, Young, Young split lang. Sorry, Young slit. And then yang mana lah, yang about wave lah. And then we also have this stationary wave. It's also part of the main component. And then the third one, sorry, it's a bit cacat here. I don't know why they do like this. So the fourth one will be the fourth one. After we study wave, we study electricity, yeah, electricity. So this one we study about the current, we study the PD, we study the EMF, we also study about the Kirchhoff law, okay, and then we also study about resistor and so on, and the basic one lah, DC circuit, yeah. And then we have the other one will be which is the fifth one, and the fourth one will be the nuclear, sorry, nuclear physics, yeah. So it'll be the nuclear physics. So this one is the one, the model of the atom lah, yeah, model of atom. We also study about fundamental particle, yeah, fundamental particle, yeah. So roughly about anulah, there are four component, I think, if I'm not mistaken. Let me double check a bit. Okay, let's have some way. think that's about it lah. Yeah. Now, so what we're gonna do today is we're gonna focus on this one lah. What we do today is we're gonna focus on the nuclear physics lah. So we try to not to make any mistake on nuclear physics, and maybe on wave, yeah, on wave. So we try to wave also we have this I forgot to mention the Doppler effect, yeah. Doppler effect, yeah. So let's have a look at this what do you call that? Let me just send to you first. Export to your Telegram first, so you can have a look afterward. Block 2. You have your calculator with you, and maybe a piece of blank paper.
Yes.
So I get ready some of the past year lah. So this is 2021, the latest one. Yeah. So we go backward lah. So we try to do at least 5 years back and see how the question look like. So this is the first one. Maybe I zoom in a bit so that you can see. Oh, this something I marked my mistake here. All right. So can you take a look at the question first? While I read it out lah. So a nucleus, uranium-23592. So I highlight this one first. And then what happened is it undergo a series of decay. During the series of decay, 2 alpha and 1 beta minus are emitted. So I can imagine you can imagine that you have 235 uranium 92. It undergo a decay. It will have 2 alpha and then plus 1 beta, right? Then you will get a daughter nuclei. If I'm not mistaken, as a result, AC is formed. So as a result, AC is formed. So what will be the correct notation for the nuclide of the actinium? Yeah, that is formed. So we do the balancing now. Yeah, let's do the balancing now. So remember, alpha is a 4,2 helium. So this one has to put a bracket, yeah, because it's 2 alpha. And then this one I need to put it a bit out here. So 1, and then we have a beta is a 0 minus 1. So this is another notation. So can you take your calculator now? I'd like you to calculate the balance, yeah, the balance of this actinium, yeah. But you try first. I will pick one of you here. Oh, so many people already. We have about 10 people now. Oh, Maria sudah. Yeah. Cuba dulu I ask one of you to give me the answer lah. Yeah. Alright, I think some of you have already done it. Maybe I see we start from the top lah. Asman, sudah you cuba Asman?
Sudah, sir.
Okay, so can you tell me what would be the answer for the actinium here?
I got B, sir.
B, yeah. So it's a 22789. Okay. Any objection from the rest?
No.
Okay. So everybody are happy with the way we do the calculation. All right. So we move on to the next one. Next one we have, this one Sanang or this one. Which of the particle is a fundamental? So this one just let me check with you. Electron is you know the family name for this. Wait, I ask one of you first. Basli, are you there, Basli?
Yes, sir.
So electron ni under what family? Still remember what family is lepton under? I know it's a long time around. It's a long
Quarks
time
ka,
thing.
sir?
Huh?
Quarks ka? Ingat eh.
Oh, okay. So never mind. We just study here. So we ask maybe somebody from here to help. Haswani, do you remember Haswani? What family is electron?
Yep, sir.
Ya, ingat lah.
Lepton apa ni?
Yeah, lepton. You are correct. Thank you, Haswani. So it's a lepton. This one is a lepton. So lepton is a fundamental particle. Okay. Hadron. Okay. Hadron, for your info, hadron is not fundamental because this is made from quarks. So just anulah quarks. Ku ni kah? K R K quarks. So for example, you have the proton. So proton is made from up, down, and then you also have a neutron. Is sorry, my mani salah. Up, down. This is a up, down, down. So this one is not a fundamental. This one is a fundamental. And then the next one here we have neutron. Tu nah. Neutron, proton, baru saya buat tadi. This is a proton, this is a neutron. So these are not fundamental. So the only one fundamental is actually A lah. Yeah. So A will be the answer. Yeah. So just to clarify, fundamental particle, there are only two. Yeah, that we need to learn. The first one is the lepton family. The other one is the quarks family. Yeah. All right. 39. Okay. Let's look at 39. You have an unstable nucleus. Okay. Go through successive decay to become a final stable nuclei. Oh, successive, meaning that it is more than one decay lah. The initial nucleus and the final nucleus are isotope of each other. Oh, interesting. How many alpha and beta particle could have been emitted during the decay sequences? Wow, this is very challenging. So let's say you have a unknown new nucleus. So we have let's say we have 40, and maybe we have 15. Maybe I make it a bit higher lah. 140, 60. Oh, sorry, 60. Yeah, to make it higher. So what I normally do kalau sir lah, what I normally do, I will put the example in lah. That's the fastest way. Yeah, for me. Yeah. So let me show you. Let's say we look at if it's a A. If the answer is A, you will have one alpha only. So one alpha. So 142 alpha. So it'll be only one alpha. So that means you will get 136. Oh, sorry. 136. This one become 58. Okay. Let's say this is your decay. Remember isotope again? Isotope, if I'm not mistaken, isotope is same proton number, but different neutron number. So in the other word is this one. Oops, go back. This one and this one must be the same. So for this case, A is incorrect. So we look at B now. So B you have one alpha. So one alpha. plus 2 beta. So 2 beta. So this is a 0 minus 1 beta. So your new daughter here will be still the same 136 tapi now you see this one is 2 minus 2 plus 2 is 0. So this one got 60 Am I right? So I think B will be the answer lah. Yeah, B will be the correct answer. Anybody want to comment about this question? Because we do until B, we get the answer already. So I don't want to do C and D anymore. Macam confirm sudah. Are you okay with the explanation here?
Yes.
Yes.
Boleh lah. Yeah.
Yes, sir.
Alright. So this one, the answer will be B lah tu. So we no need to do further on. Alright. This one I'll ask one of you to tell me the answer. So you read first. You read first, Adi, strange. I don't even remember the charge of strain. Plus 1/3? Yeah. Plus 2/3. Minus 1/3 plus 1/3? Yeah. Alright, so maybe some of you have already answered. So maybe I ask, a lot of people left already. Faiza, Faiza, what will be the answer, Faiza?
Don't know, sir.
Don't know.
My guess was C pula.
Oh, your guess is C, Maybe you are right, maybe you are wrong. So you need to look back at the charges carried by these quarks first. So hang on. We open our Google to help us. So we type in here charges. For each up quark has a charge. Or maybe we look at this one. Image saja lah. Faster a bit. Yeah, tu nah. We have the charges here. So if you can see here, strange is actually minus 1/3. Chum and strange, yeah. And then up is 2/3. So we make a statement here lah. Payah, soalan ni payah ni. So up is plus 2/3, and then the strange is minus 1/3. Sorry, minus 1/3. So you were saying the answer is what again? You're saying the answer is C. So let us cuba. So we have plus 2/3 plus 2/3 minus 1/3. So we have 3/3, which is a plus. So you end up in plus 1. Tidak boleh Faiza. Pasal ia mau minus 1. Kan? So your answer...
I thought dia tanya. So kan hadron dia proton neutron. So I thought tadi proton wah.
Ia mau ia
Berarti.
punya charge. Ia tak trik kan tu.
Confused.
Yes.
Sorry.
So yang mesti maybe is this one kali ya.
Mesti minus 1.
Yang
D sir, D.
D even worse. Plus 2/3 plus 2/3 plus 2/3 jadi
Ayu je tu
6/3. So it's a plus.
Aku fikir D sir. S salah.
So I think it's a
Yeah,
SLS is a A actually.
Yes.
So it's a minus 1/3. Oh, sorry. Minus 1 over 3,
Oh,
minus 1 over 3, minus 1 over 3. So you got a minus 1. Yeah. So A will be the
Yeah.
answer. Lah. Oh.
Dapat malam.
Oh. So
Malam-malam kalau
it's
mata.
okay lah. Oh. It's okay lah. We all try to learn lah. Yeah. So we take another paper lagi. This time we take 1/9 lah. I take one paper from 1 year lah. Some from the June, some from the November. Mana kan papernya? Paper November we do 1/3 lah. Sabar ah. So this is a 1/3. We look at the last question. Copy and paste dulu ah. Mana kan last question? So this is the last question. I cut into the other side first ah. So that sekarang I can share with you all the slide. Not this one. Mana dia? This one. Yeah. So this one I come back here. Paste image. Dump it. Never mind. Make it bigger afterward. Kejap ah. I get another year lagi ah. So this one is okay. Take another year. 1/8 lah. We use 1/8. So let's take a 1/8 November. Let's take a question number 1/1. Yeah. Lagging a bit. Yeah. So this is a 1/1. Okay. Last question. Yes, selalunya last 2, last 3 dah. So we do some lah. So malam ni we try to practice this one. Jangan salah time kamu exam sekarang. Try not to make a mistake from here. Paste the image. Enlarge it. Enlarge it some more. Yeah, good enough. Alright. Maybe last one. 2001/8. Now we get a 17. Yeah. Kejap ah. You get ready your calculator saya lah. Yeah. 1/3 lah. Yeah. This is 1/3. I forgot to. Oh, this one banyak ah dalam ni ah. Oh my god, this is 4 question about this
Quantum.
nuclear physics. Yeah.
Oh.
Kejap, sabar. Copy it first. Oh. Alright, so sabar ah. Too big. Just a bit. Just a bit. Yeah. A bit nice. So we come back here again. And the last two. Alright. So we have some exercise for us to revise. Come back here again. So paste image. Make it bigger. Oh, too big. Smaller a bit. Yeah, it would be nice. Alright. So let's look at some of the past year question again. Oh, ini mati loh this one. Number 39. Yeah. 39 main apal ni this one. 39 ni there is no other way you can remember this one. Diameter of a typical nucleus. Yeah, order of magnitude of diameter of typical nucleus. So I need the help of the Google to help me. Pasalnya tadi ya. Diameter of a typical nucleus. So type here. Diameter. Kalau time paper 1 boleh buat macam ni. Back jaw. Typical.
Kalau exam boleh buka internet ke tu sir?
Payah soalan semua ni. Oh tu nah. Minus 15. Nak ada answernya. About 10 to
Yang
minus
hampir kali
15.
sir.
Huh?
Yang hampir saja kali.
So this one tu A ya.
Oh,
Sekarang
estimate.
pasal take answernya tu. What is the diameter of a nucleus? 2 to the power of, or is 2 to the power of minus 15. So you run off to, jadi 14 ke dah. Kejap ah, let me do my maths here. 2 times 10 minus 15 meter. Komo ia jadi 10. Komo jadi 10. 10 times 10 power of, ya kalah. What is this mean? This is mean 1 betul ah. 1 times 10 power of minus 14. Sama je ah. Cannot get the answer. Typical atom diameter of an atom. This is an atom, sorry. Not the answer. Diameter of a nucleus. Minus 15 the answer. Because I don't trust this answer. There must be something wrong, but that's the best we can have lah. Sekarang tak check ah. I forgot to cut and paste the year, so never mind. Yeah. All right, next one here. Have a look at the next one here. Beta minus decay in terms of simple quark model. Alamak. This one semua main memorization. Yeah. Kalau beta minus, okay, is a neutron. Neutron 1 0 break down into a proton. Sorry, it's a 1 1 p, and then plus a electron 0 minus 1, and then plus the anti-neutrino. Okay, so mesti ingat this one. You must remember this beta minus. Kalau beta plus will be the other way around. So as you can see, this one is a neutron. So it's a up, down, down. And then this one is a proton, is a up, up, down. So this is the transition lah. This is the transition here. So let's have a look at the answer here. A down changes to a up. Is it correct? Let me see. One of the down changes to a up. Makes sense? Yeah. And then electron is produced and anti-neutrino are emitted. Oh, that's the answer already. Yeah. So the answer is already this one. If you have doubt, we have a check lah. A down become a up. Okay. Down become a up. Correct. A positron. No, there is no positron here. So this one is incorrect. And then we also have a up changes to a down. Oh, tidak boleh. We don't have a up changes to up. This one is also wrong already. And then a up, this one is already wrong. So these are already wrong. So the answer is A lah. Yeah. So for your information, I think you better remember this beta minus punya expression, which is a lot to remember actually. Paning tu. Yeah. All right. Next one. A nucleus emit beta minus particle. What is the chain to the proton number and the neutron and the nuclear number of the nucleus? So the proton number and the nuclear number. So macam mana buat? Normally I will use a example lah. I'll use example. Let's say we have the X again. X 140 60. Emit a beta minus, yeah. Beta minus is a 0 minus 1. So the new element or the new nucleus will be 140. Here become 61. Okay, here becomes 61. So I do a quick calculation of the nuclear number. Nuclear number is the MR, betul ah? Yeah, MR. So the MR here is 140. The mass number here is 140, and then the proton number here is 60, and the proton number here is 61. So if I look here, there is no chain. Yeah. So this one no chain. And then if I look here, we have a +1. So the answer must have a +1. Proton number must be +1. Proton number must be +1. And then there should be no chain here. All right. So for mass number, or the nucleon number yang di atas ni, there is no chain. So it will be, the answer will be D lah. Are you okay with this one?
Yes.
Okay you happy with my explanation But this one you read first. This one you read first. I'll ask one of you to explain to me lah. Yeah. So basically we revise wave and nuclear physics today Kira touch up lah. Alright, I think some of you are done already. So just now I asked Bazli, Faiza, Ian. Yeah.
Sekejap.
Oh, belum. Belum. Oh, banyak rupanya. Okay. Kalau Ian, you have answer, you let me know.
Okay, sir. Sekejap, sir. Sir, B ke?
B. Okay. We have a proposed answer. B. Let's check the answer lah. Yeah. So you have chlorine 3717. So we have 17 proton and we have 22 neutron. One proton has a up down, and then we have one neutron, you have a up down. So meaning that you can say there are two up and one down. This one is a one up and two down. Wow, this one has to do some maths. Kalau 17 of them, there will be 34 up and 17 down. 20 neutron, there will be 20 up and 40 down. And then after that, you do the maths here. You'll be 57 down and 54 up. Yeah, I think you got the answer, Ian. The answer is B. Oh, highlighter pulang. Yeah, B. Okay. Do you like this kind of question? I don't like actually. Because it asks us to, what do you call that? It's not a direct question. Yeah, we need to know this content. Without this, you cannot do. That means you die. And then you also need to know some chemistry. Yeah. So if your chemistry about this is very poor, then also you cannot do. So this one will be a killer question. Yeah. All right. Are you happy with the answer, everybody?
Yes.
Okay. So now, give me a response je lah. Yeah. We have to be interactive lah. Stop me if you find that there are something wrong with my explanation and so on. All right. Next one, 37. Let's look at 37. You have a look first. I also try. Yeah. Semua cuba dah. Yeah. I hope you use a PC to look at the screen. Kalau mobile payah tu. Terpaksa kamu pakai Zoom lagi tu. You can zoom in, right? The share screen, right? Yeah.
Senang je, sir.
Yeah. Okay, bah. Wai, let me know the answer, wai.
Sekejap, sir.
Nah, belum lagi kira sangat. It's extra.
2, 3, 8.
Payah ni benarnya. Sakit kepala kira tu. Pasalnya ia ada
Ah.
alpha sama beta bah. Kan? Kira try error benih.
Ah.
So is kalau for me lah, kalau sir lah, sir pakai try error, sir put the answer and test one by one. Yeah. So contohnya lah, I show you here. 2, 3, 8, 92. Contohnya saya pilih A lah. So there are 6 beta. So 6 minus 1. 6 minus 1 beta. Plus I don't know how many alpha are there. And then the end result is a 20682 PB. So I do my maths now. So this is 206. That means alpha is 238. Meter each step. 238 minus 206. 32. This one will be 32. And then we have 92 plus 92 minus 82. And then minus 6. We have 4. Which is not possible. Okay. Alpha cannot have this.
Sir.
Ah.
Bukan A.
Bukan ya? Kejap. Salah kah? Yang sir punya answer ni ngam kan ni son? 32. Number
Yang di bawahnya.
Bawahnya
Di
salah.
bawahnya 16.
Oh, what? 16? Macam mana aku dapat 16?
82 plus 16 minus 6 is 92, sir.
Astaga. What did I do with my maths? 92 minus 6 plus 82. Kejap. I think something wrong with my maths. Minus. Okay. So it's 92 minus 6 plus 16 plus 82. So this is 92 lah tu.
Yes.
My algebra failed today. I got a 4.
It's okay. Malam.
So 4 meaningnya boleh betul. This one will be 34 divided by 4 is 8. 14 divided by 2 is 8. So they are 8 alpha here. Yeah, there will be 8 alpha here, which is the number lah. 4 2 alpha. Yeah. So if you try yang lain atau, I think you cannot get the answer. Yeah. I think yeah, cannot get the answer. Yang tamu tu. Yeah. Alright. Oh, this one senang lah. This one correct or wrong saja. So let's have a look here.
Yes.
Macam sana. Alpha. Okay. Alpha emit from a single radioactive isotope, has a continuous distribution. Alamak, I don't remember this one. It's a fact lah. Continuous distribution of energy. I remember alpha tu is a fix lah. Dia punya energy tu is not a continuous lah. Kalau continuous, if I'm not mistaken, is beta. Kalau nasib lah, ni man, we have to read first. That's why lah. Kadang-kadang you don't revise back, mana ingat lagi tu. Ionizing power, oh this one I know. Ionizing power alpha is the stronger. So I know this one salah sudah. I know B already is wrong. The charge, salah. The charge of alpha is, mana boleh kan. Remember the charge, alpha is a 4-2, so has a plus 2e. So plus 2e is actually 3.2 times 10 to the power minus 19 coulomb. Tidak ngam. So this one is wrong already. The speed of alpha can be as high as, alamak, I also don't remember this one. So now we have a dilemma here. Okay, I have either A or D. Tapi yang saya ingat kalau continuous distribution ni is beta. So let's have a Google here first. Don't worry, we have Google to help us.
Nanti boleh Google lah, sir.
Ha?
Nanti
Google
boleh
your
Google.
own brain je lah.
Apa
Betul
sah?
lah. Macam mana yang tahu ah? I didn't say anything bah. Sudah macam ku search. Harus ah.
Itu sir,
Continuous energy.
common question, sir.
Semoga
Common
search
question.
kali.
Ada orang search kali sudah sir.
Tawa.
Itu nah. Why beta is beta continuous or discrete? Beta has a continuous distribution of energy. Okay. Why is beta continuous? So it's ngam lah tu. It's a continuous. So my memory is ngam lah tu. So this one must be beta. Kalau continuous energy is beta. So that mean my argument will be this one will be the wrong lah, and the correct one will be D. Sekejap ah, just to confirm confirm here. Speed of alpha. Yeah, let's do a speed of alpha. Speed of alpha particle. Alright. So what is the speed of alpha? 5 to 10% speed of light. Ada. Tu nah. 6 kali ah. To the power of 7.
Ngam, sir.
Point. Oh,
Ha?
sama
Sama?
sah.
Ya.
Oh.
Sama-sama. Tu nah.
Tu.
20,000 bah. 20,000 1, 2, 3, 4, 5, 6, 7. Ngam lah tu. So this one is correct lah.
Sir,
Alright. Yes.
betul. Alpha particle, sir. Kalau energinya, kalau tak buat energi, apa sir?
This discrete energy. Alpha should have discrete energy. Meaning that kalau kau ada let me draw here. Contohnya this is your alpha punya source ah. Semua tu sama bah. Contohnya 1 millijoule, ani pun 1 millijoule, ani pun 1 millijoule, ani pun 1 millijoule. Semua sama. Kalau beta dah dapat, beta ia ada banyak jenis. Kalau beta ani maybe 0.5 millijoule. Ani maybe 0.1 millijoule. Ani maybe dalam 1 millijoule. Ani maybe dalam 0.7 millijoule. That's why ia continuous ah. Semua ada continuous distribution of energy. Yeah. So that's the idea lah. Alpha is discrete energy.
Okay, sir.
So quite interesting lah. We learn this one also. I try to share with you what I think during the exam. Oh, this one should be doable. What I mean by doable, kalau dilihat this is a beta minus. So this one is a beta minus decay. So you need to recall again recall kalau beta minus, ia akan dari neutron to proton plus electron plus anti-neutrino. Yeah. So the answer will be anti-neutrino. Yeah, A will be the answer. Kejap. Electron is the ani sudah bah? Yeah. Neutrino bukan, positron bukan. So A the answer. Because beta minus is the electron already. We have the same question come out just now. Yes.
Positron apa sah?
Positron is
Positron.
just the reverse of electron.
Okay.
So this is electron, which is E minus. Kalau positron, sorry, handwriting cacat salah. Positron, it will be either you write a E plus, or you can write a P je boleh lah, whichever you like to call it lah. E minus also can. This one, the answer, no other choice. A. This one, salah. Yeah.
Okay, lurus.
Alright. Done. Now, it's time to you practice lagi lah, the nuclear physics lah. Most of them is about this quarks lah. Yang paling challenging is ni lah. Kadang-kadang ia factual lah. And then ada lagi yang nada lah. I want to show you the Giga Marsden one. So maybe tomorrow lah I try to share with you. Alright. So now we look back at the 3-4 years back again. We look at wave now. We look at wave. Oh, lawa je gambar ni. Oh, 28. We do backward lah. Yeah, wave. Okay, I think taruh saja lah. I send taruh the soalannya lah. Alright, now we are doing wave. We're doing wave now. So you have to switch your brain punya memory cell to all you remember about wave. So let's look at wave now. 29. Okay, so you have a blue, you have an unknown wavelength, and then you have a blue color single wavelength are both incident normally at the diffraction grating. 2 diffraction patterns are produced, 1 for each wavelength. Okay. The third order of the blue light occur at the same angle as the second order of the unknown light. The wavelength of the blue light is 480. What is the unknown wavelength? Oh, so how do we supposed to do this? Yeah? How are we supposed to do this? Maybe I cut and paste saja dulu supaya sekarang you can see. Sorry I cut and paste saja dulu lah. Give me a minute Maybe I put here lah. Taruh saja lah. Yeah. So I put into here. Okay. Give me a moment where I set up the question. So the first one, we have this one. Pasal basar punya soalan ni. Okay. So we have this one. The cut pun never mind lah. Yeah. Still can see lah. Yeah. So this one, I'll make it a bit bigger. Yeah. Oh, too big. Yeah. Then come back here again. Ada lagi kah about wave? Ada banyak rupanya wave ni. Yeah, banyak rupanya. Okay. This one we do last lah. Then after that you go home and you go home lang. After that you already at home.
Already home, sir.
Then after that you do some more lah. Okay.
Okay.
Sekejap I should have do this just now. Lupa. Rupanya web ni banyak rupanya. So never mind, we just lah. Just do as many as we can. Okay. Sekarang sir send the slide. This one to you all lah. You have a look lah. Okay. Dan ada lagi kah? Oh, banyak rupanya. Oh, this one habis. Last one. Okay, sabar. Sabar Almost there. This is the last one. After this, we can have a look at the question. Okay. But we do backward lah. Okay. So everybody get ready with your maybe calculator or whatever. We look at question number 21 first. We look at question 21. So 21 is about you have a wave. Identical produced by a source at P and Q, the wave travel along different path to reach R. So you have to imagine lah, you punya wave like this, ching 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 ching. Okay, the wave is coming like that, and the other side also you have another wave. Oh, macam mana ni wave-nya? Shoo 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 to the P here. So kejap nalawak. I think salah. salah. It will be like this, sorry. Wave like that, yeah, like that. And then the other one will be like this. Yeah. So both have a wavelength of 6. Yeah, both have a wavelength of 6. So both have a wavelength of 6. The wave are in phase. Okay, the wave are in phase at point R. So kalau in phase mean the path difference must be 0. Yeah. Kalau in phase mean the path difference equal to 0. So what I mean by path different, we have I need somebody, everyone lah. Can you take out your calculator? Can you do for me 80 cm divided by 6? How many wavelength are there? Yeah. 80 cm.
13.3.
13.3.
13.3 tidak ngam leh. Why the
13 1/3.
Okay.
Mesti tukar ke meter ke sir?
This is wavelength. Because
Okay.
one wavelength is 6 cm. This one 100 divided by 6.
16.6.
16.
16.6.
So it's 16 2/3, right? Okay. Kenapa soalannya macam nangam ah? Both wavelength are 6. The wave are in phase at point R. This is in phase, so meaning that the phase difference here must be 0. The phase difference here must be 0. What is the phase difference between the wave as they pass between P and Q? What is this? Somehow my head also jammed now. What is the phase difference between the wave as they leave point P and Q? Point P and Q. The path difference here, kalau you minus, how much you get? Also, it's not a whole number. 13 1/3, 16 1/3 minus, wait, 16.666 minus 13.333 is a 3.3. Selalunya we find out sini betul. Selalunya we find out here. Yeah, this is what we try to find out the phase difference. Tapi sini sudah kena beritahu sih. The wave this one is already kena beritahu. So we want to find out here. But why there? Any idea? Anybody here? Somehow my head is not
Cari
working.
angle ke?
Jadi angle.
Never mind.
Macam mana?
I
So,
think D kali sir.
Kan
You saying the answer is D? Ian ba?
Jangan
Why?
nama aku
Why
sir.
you?
Orang buat ya.
120.
Entah sir, what I think lah sir. The 100 centimeter one is 16 2/3, and the 80 centimeter is 13 1/3 kan sir. Maybe lah. Pasal Ian ada mention diorang travel at the same time kan. Maybe lepas a moment, the 80 centimeter baru berjalan sir. So 2/3 minus 1/3 becomes 1/3 kan sir. So 1/3 times 360 is 120, is it?
Oh, alright. So you're saying that macam mana ni betul? 16 2/3 and then the 13 1/3. You are taking this one, right?
Yes.
Ngam gak ya? Then you get 1/3
Yes, sir.
and then you
Hmm.
time 160 120.
Kenapa?
This
Wow,
is
yeah. Wow.
Let's check the answer.
Yang wow dulu. Ngam kau salah je.
Kenapa
one.
time 360?
Ngam tu.
Kejap. Let's check the answer. 21 June 2111. Okay. Question number berapa tadi? Question number 21. This is the moment of truth. Import the 2111.
Kenapa aku rasa jawapannya B?
Oh.
So this is the answer. 21. Oh, the answer is A.
Jauh.
Jauh dah.
Nampak? June. Confirmkan dulu. June 217. Sorry. 17.
Astaga.
Aduh.
Panik saya.
Salah suspend ni. 21 tu nah. 21 June 11. Okay. 11 tu nah. Jom lock dulu ah. Okay, question 20.
Drum roll.
1 D. Yeah, D is the
Wow.
answer.
Wow. Yeah.
Damn.
Tapi kenapa pakai yang ia punya ujungan ni ah? I mean, why we have to use the ujungan ni? Labingnya kata ah.
Kena difference kata.
Kira
cari difference-nya kali 360.
tapi sebenarnya kalau
Okay.
kau lihat sini, difference-nya should be 3
3.
Kalau
3
3 360 dia
3. Oh. 3/3 times 360, you have how much? 3
1000.
macam mana?
Ya.
Apa sah?
3 1/3 times 360. How much ah?
60.
1 200
360.
200.
Oops. 3.
160 kah?
3/3.
Times
Aku dapat
360.
200.
3/3 times
3 1/3
360.
times 360.
360.
3 oh 3
360.
360.
Satu
Three
persatu
over
ya?
three, 1.
1/1 itu.
Apa kan?
Ya.
3 1
Wait,
over 3.
bukan dah tu. Fix.
3
Oh.
over 3.
Iya,
Oh, 3 1/3.
Oh,
Bukan aku.
bukan mix number kan tak?
Kan ya,
Please
12,
tambah.
16 2/3 minus 31/3, then you get this one lah.
1200. 1,200. Aduh.
Dapat. Malam.
Malu.
How much ah? 1200 lah. 11200.
Yes.
1200.
1,200.
1200.
Tapi setria tu bukan boleh masukkan kan?
Eh,
Is a
Setria
3
tu boleh
wavelength.
masukkan kan? So 3 wavelength is
kalau-
360 degree kan?
Oh, okay. I think I start to understand already because 3 ia punya path difference-nya. The path difference-nya is 3 and 1/3 wavelength, kan? So this is already 3 times 360 is how much ah? 3 times 360 is 1080. And then the remaining one must be 120. So this will be the answer. That's what we're trying to do here lah. What will be the phase difference as the wave leave P and Q? So it will be this 120. Yeah. So I think macam mana lah. So rather than just take the fraction minus, you minus the whole thing lah. 16 2/3 minus 31/3, kau dapat 3 1/3 times 360 ah. You get 1200. But this is by a gap of 3 wavelength and 1/3 wavelength. So 1200 minus this, the remaining will be the phase difference ya lah. macam itulah. Yeah. So this one I think I will also maybe not score here also. So it's quite a kind of
Artinya
weird.
jangan keluarkan.
Oh, that's why.
Nah, dah
Jelas,
boleh.
jelas.
Okay. Sekarang tomorrow
Sir.
tomorrow
you
saya
got-
check kalau yes.
How you got the 120 from 1080? Divide by
120
the
This one is
1080. Lepas tu
3 times 360 ah.
okay.
And then the jumlah is 1002 lah. Dari atas ni ah. Jumlahnya is 1002. So this one must be 120 lah.
Okay.
Sakit kepala web ni.
Okay, sir.
Bagi takut. Alright,
Jangan
20.
takut kan.
Sekarang saya cek. Tomorrow saya cek. Kalau ada, saya buang dah.
Ya, okay, sir.
22.
Bagus.
Okay, 22. Let's look at 22. Longitudinal wave. Longitudinal wave is, got like compression, rarefaction, compression, then the rarefaction, and followed by compression. Compression, rarefaction, compression, rarefaction, compression. So let's continue. Left to right has a vibration polaro memang. The wave can be represented in a graph, show the which point is the center of the compression? Alamak. The center of the compression. This is the distance from source. Distance from source. Direction of energy. Displacement maximum. Displacement. This has a lot of displacement. This one, no displacement. Tapi ada dua answer. Yeah, there are two answer there. Why I choose wave? Lagi paning lang. Positive displacement, negative displacement. So you bayangkan, this is the spring. So the spring is going this way, and then what happened is your spring has to move front and back. Yeah, your spring has to move front and back. So this is the center. The center of the displacement. So we go, let's say we go forward is positive displacement, go backward is negative displacement. So as you move, distance from source, let's say 1 meter lah. 1 meter you move forward, so the distance will be on the positive side, okay? And then 2 meter, you go back to the original place, the B here. Alright, so the displacement, and then at 3 meter, let's say now you go to the left. Yeah, this is left, this is right lah. So you go to the left, and then at 4 meter, you go back to the point here. So compression, which one would be the compression? I got the dilemma here. Yeah. Displacement, compression. Oh, maybe you think of displacement. So this one is the fastest. So kira your spring, you move left and right. So at the center, it will be the fastest. Okay, you move left and right, kan? So your spring will be the fastest at here. At the zero displacement, it will be the fastest. So meaning that this one will be the fastest. This one will also be the fastest. But this is time, it's against time. This is against distance. Against distance. Alright. Anybody want to have a guess first? What's the answer?
B, sir.
B for boy.
Ah.
Okay. Any other answer? So we learn later on with the answer lah. So anybody have any other choice other than B? Nada. So assume everybody happy with B. So let's look at the answer here. Number 20 berapa tadi? 23 lah. Kejap. I also don't remember now. 22, sorry. 22 just now the answer is B. Yeah.
Yeah.
Itu nama is B. Tapi why B ya? Kenapa anda C? Kenapa anda rasa?
Why you explain?
Why you explain lah?
Sir. Yeah. Sir. Aku rasa lah, sir. Kan ada dua tu, sir. Apa ni? Apa namanya? Maksimum. Bukan. Zero displacement. Awal. Apa tu?
Which point is the center of the compression? Center of the compression. Because my guess is also B. Ian, you have any idea, Ian? Why is it B, Ian?
Aku tak tahu. Aku ni bagus sama graph.
Oh, bah, macam panding macam mula-mula sebab pun I suspect already is this two point here, but it's coming back, bah. Yeah, it's coming back. The spring direction, distant from the source. Displacement. I don't like this wave thing. Parallel to the direction of the energy. Make sure that displacement. Figure out the center of the compression.
Center. Sir.
Yes.
Kalau term 0 tu, dia di mana? Is it the middle?
Arah sini. Yes.
And then
here.
Sama je BD sama yang ujung atas.
Oh.
As long as you are x-axis.
But the problem is, this is not a time axis. It's a distance axis.
Kali itu Kaisa, dia ada 4 kan, itu divide by 2. Dia tengah-tengah, 2. Yang kedua. Kah?
Apa? Divided by 2.
Dia ada 4 points kan tu secara maksimum tu. 1, 2, 3, 4. So yang mau center, so divided by 2. So antah
Ini mana? 1, 2, 3, 4. Sekejap. We look at the another dulu. 2021 Sekejap. Number 22 kata tadi ya. Okay, sabar. Number 22 2021 examiner reportnya si adakah? Belum ada report. Oh, sorry. We don't have the examiner report here. Okay. Because I got 2 answer here. But this is a spring. This is a distant time graph. Meaning that this one is like macam like you take a photo. Macam kamu gambar spring atau. You take a photo and then you see the displacement of the spring. Okay lah. We just leave it first lah. 22 is B ya. Yeah. Kejap. I erase this one first. Alright, never mind. Last one for today lah. Yeah. Last one for today. Yeah. So look at this one is about Doppler effect. So Doppler effect. I think it's a Doppler effect planta because I see the frequency of sound. So let's see how do we answer this. A stationary wave is formed. Oh, not a Doppler effect. Sorry. Standing wave. So let me draw a standing wave here first. This is a standing wave. It's formed from two identical sources. Microphone is placed at the position of maximum loudness. So let's say you put your microphone here lah. This is your microphone here. It is then moved along the stationary wave from the first maxima to the fourth one. Oh, sorry. I better draw the microphone here. So this is your microphone. So here is a maximum loudness. So he pindah here, another the first position, then second position, then we have the mic here, we have the third position, and the last one is the mic here. We have the fourth position. Okay. Let me double check again. A microphone is placed at the position of maximum loudness. It is then moved along the stationary wave from the first loudness to the fourth loudness. So 1 loud, 2 loud, 3 loud, 4 loud. The microphone moves a distance of 12. So the distance traveled by this whole thing is 12. So this one will be how much? 444, but 444. Yeah, it's a 444. What is the frequency of the sound? All right. So remember, for a standing wave, this is your standing wave. So from maxima to maxima is only half wavelength. Yeah, it's only half. Belum habis tu. Ya mesti. So this is only half wavelength. This is another half wavelength, and this is another half wavelength. All right. So in 12 cm, there are one and a half wavelength. Yeah, 1.5 wavelength. So your wavelength will be, you cross multiply now. So one wavelength is equal to x. So 12 divided by 1.5, you get 12 divided by 1.5, you get about 8 cm. So this one is 8 cm, which is about 0.08 meter. All right. Now we can use our formula. V equal to F lambda. F is equal to V over lambda, and you can apply the speed of the sound, 330 over 0.08. Yeah. So 330 divided by 0.08, you'll get 4125. Yeah. So the answer is 4125 hertz, and the nearest will be A will be the answer lah. Yeah. All right. So this is the last question for today. Number 23. Yeah. Yeah. How I do it, I show you here already lah. Yeah. So I hope this one is more digestible. Yeah. Any questions so far before we call it a day? Yeah.
Sir,
Yes.
maximum loudness, sir, arah not ke anti-not, sir?
Arah anti-not. Oh, sorry, sir. This is anti-not. Sorry. Anti-not. Yeah, correct. Yeah. Anti-not.
Anti-not.
So this is anti-not. This
Maximum
is a
loudness.
not. Yes.
Pasal sir, last time aku cek Google, sir, katanya maximum loudness arah not, oh, sir.
Maximum loudness arah not.
Yes.
Let me check here. Oh, sorry. Type here maximum. Mana dia keluar loudness at not. Oh, anti not.
Not.
Not. We know that the anti-not
Not.
is the maximum, the pressure change the minimum, while not is the zero pressure due to variation. What is the maximum in the case of stationary wave? Because we know kalau you lihat sini the Britannica ada dia show the Britannica ada yang show maximum displacement is called anti-knot. Distance between successive knot is equal to half the wavelength. So where will a person hear maximum and not anti-knot? So we see this one, the three answer there. Where will a person hear maximum and minimum? Pressure variation, pressure max knot. Ada. No. That's not the answer, right? Ada answer yang kah? Ada pun? Cannot see the answer. Go back. Yeah. That is something new, yeah. First here, where does the person? Let me check the answer first. This is number 23. Mana tahu salah orang. 23 last one. 23 is A. Yeah. So I got the answer correct. Cumanya we have a argument here. Suppose you hear the loud sound arah knot. A person will hear loud sound at knot. Then we know that anti-knot the maximum, pressure changes is minimum. While at the knot, the displacement is 0 and the pressure changes is maximum. The sound is heard due to the variation of pressure. Also in stationary wave, particle in two different segments vibrate in opposite phase. Interesting, yeah. So according to the statement here, just like what Ian said, you will hear loudness at the knot, the knot. Tapi kalau saya ingat, if you move around here, you will hear loud, quiet, loud, quiet, loud, quiet. But anyway lah, kalau you use knot pun, kalau kamu pakai sini pun sama je lah. Contohnya tu, kalau you use this one, you end up in the same answer also. Yeah, just in case we are not sure where is the loudness. If you use the knot as the loudness, ia punya distance pun sama tu. You see, first, second, third, fourth. So here will also be 12 cm, and then you also get 4 cm lah. So Ian, just for our understanding, maybe at knot you hear the loudest, but the technique should be the same lah, Ian. Kalau kau pakai knot
okay,
pun
sir.
sama je lah, get the same answer. Kalau kau pakai anti-knot ataupun you get the same answer je lah. So no need to worry about how to get the answer lah. Bah, I'll call it off a day. Yeah. So tomorrow we continue again lah in our own blog. Oh.
Thank you, sir.
All right.
Thank you, sir.
Yeah.
Okay, sir. Thank you, sir.
All right. Good night.
That's
Okay, good night, sir.